So if folks are cool with it, I'm just gonna, I guess, do some preview of what's coming up. I guess maybe sort of. Um, we'll do a little bit of degrees and radians and that sort of thing. So let me pull up a Khan Academy or pull up Khan Academy. We will look at a couple of the brand new assignments as well as the one assignment that I pushed to this week. As always, you can make a comment in chat, or you can, there are only two of you. Just let me know if you need anything. Just say something, it's fine. All right, so we're gonna start, and I know you're still seeing me and not the thing, because I'm gonna do some copy paste, and then we'll move over to the whiteboard. Okay. So radians and degrees, right? That was the, or degrees and radians. I don't remember which one it's called, but that's the name of the assignment that was due at the end of last week, but I pushed it for a week because we didn't get to it fast enough. So I want to give you both some practical stuff so that you can apply it to Khan Academy right now. And then I'm going to talk a little bit more about radians. And maybe if you ask me some questions, I might be able to make a better next video. So let me know. The big thing about radians and degrees is that 180 degrees, half a circle, is the same as, actually, I'm not even going to decimalize it, as pi radians. Okay? Yeah, it's kind of weird that we are defining a unit with an irrational number, but there's nothing wrong with it. We're allowed. 180 degrees, halfway around a circle, is pi radians. 180 degrees, pi radians. That's our conversion, right? Whereas the conversion between inches and feet is 12, the conversion between degrees and radians involves 180 degrees and pi. I might need to turn down the sensitivity of the mic though, because I'm pretty sure you can hear that damn bird that's hanging out outside my door or my window. Okay, so we have 14 pi over 9 radians. Okay. And I want to get degrees instead. Well, all unit conversion is multiplication. And again, those of you who keep coming back, Nate especially, you hear me say this over and over and over again, so much of IM2 is just multiplication and division. We're going to multiply by 180 degrees over pi radians. Weird. Why can't I see chat? Ah, there it is. Yeah, Khan Academy was super good for this one. Sal is really great at explaining this stuff. And honestly, like, we've done this, I think. I'm pretty sure in our class we did like the miles per gallon demo at one point. Like, it's a one-step unit conversion. The reason that we put 180 on the top and pi on the bottom is because you want to have radians on the top and radians on the bottom so that they cancel, right? Radians divided by radians is 1, so we can cancel it out. And hey, look, this pi on the top and this pi on the bottom also cancel, which is nice. That won't always happen, but it's nice when it does. And let's see. I know that 180 divided by 9 is 20. And 14 times 20 is 280 degrees, I want to say. Questions? Now, going back and forth between degrees and radians is really just an exercise in multiplication. It's not the point. The point is that radians are really, really useful for finding arcs, and we'll talk about that in just a sec. Let's do one in the other direction, just to make sure. So I've got, let's say, 90 degrees. And we want to convert that to radians. Well, now we have 90 degrees. That's over 1, right? Everything is a fraction. You can just put it over 1. And again, we're going to multiply by our scale factor. But because we're going the other way, because degrees is now on top, we're going to put the 180 degrees on the bottom and the pi radians on top. Again, there's not a whole lot of mystery here. The reason we're doing that is because we don't want degrees. The whole reason that we're doing the conversion is because we don't want degrees. So we have degrees on the top, degrees on the bottom, they cancel out. Uh, 180 divided by 90 is 2, so we get pi over 2 radians. The bird agrees with me. Okay. Any questions about degrees and radians? That's one assignment, and there's a couple of quick examples. The second one is called arc length, like with radians or something like that. I don't know the exact name of it, but it's arc length again, but it's using radians. And oh man, is this easier? This is so much easier. If you saw my video on radians that I put out earlier today, the whole reason that we have 2 pi radians in a circle, so we've got a circle, right? And all the way around the circle is 360 degrees, or 2 pi radians. And the reason we use that 2 pi is specifically to make arc length easier. I'm going to do this once the sort of wrong way, but I want you to see how it simplifies out, okay? Because again, I don't know whether you saw the other video or not, and it's fine if you didn't yet. So let's say I've got a circle, and in that circle, I've got, let's call that, let's see, it's more than 90, it's less than 1, or so we'll call it maybe 120 degrees. Yeah, we'll call this like 120 degrees, but we're doing radians now, so God, I should have prepared this ahead of time. 120, well, let's find out. 120 degrees. I need radians to make the problem work, so let's find out. 120 degrees, how many radians? Well, pi radians on the top, 180 degrees on the bottom. Degrees cancel, tens cancel. Looks like we get, they're both divisible by 3. They're both divisible by 6. So we get 2 pi over 3. Okay, 2 pi over 3 radians. Sorry about that. Should have had that ready ahead of time. And let's say the radius itself is, I don't know, like 12 inches. We'll say it's a foot. Okay, 12 inches. So it's like a medium pizza, right? I think a medium pizza is 12 inches. And you've got 2 pi over 3 radians. And we want to find this arc length. Now, originally, when we had degrees, we would have taken our angle and we would have divided it by 360. And then we would have multiplied that by 2 times pi times the radius. Right? It was the ratio times the circumference. But it's not 360 anymore because we're using radians and not degrees. So we're dividing by instead 2 pi. And the reason that we did that, and the reason that we chose 2 pi as the total angle in a circle, is because now we have 2 pi on the top and 2 pi on the bottom, and they just cancel. And they cancel every time, so you never even need to write them anymore. Okay? The shortcut for finding arc measure, or for finding arc length, is that arc length is the radius times the radians. That's the way I always remembered it. The reason that we chose 2 pi radians to make up a circle is because now we have a unit that says, oh, look, all we have to do is take our radius and multiply it by the angle, and we've got the arc length. It makes it so much faster. It makes it so much more efficient. It allows us to do things in fewer steps. And it's a little bit less arbitrary than degrees. Like, we chose 360 degrees because we've just been using that number for a very, 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 very long time. 2 pi we actually chose because it's useful. So in this case, the length would be the radius, which is 12, times the radians, which is 2 pi over 3. And I do some canceling. Both of these are divisible by 3. I get 8 pi. And I believe on Khan Academy, it wants you to keep it in terms of pi, but it might say that you can do 3.14 if you really have to. But I mean, really, why? That's adding an extra step. Questions on that one? Ooh. I'll try not to slap my laptop off of the desk. Okay. As a note, it won't always give you the radius and the radians. Sometimes it'll tell you the arc length, and you'll have to figure out the radius, which you would do by dividing, right? Because it's just more proportions. It's literally just more ratios, more proportions. We've been working on the same exact set of skills since similar triangles. Okay. So that is finding arc length when you've got radians. The next one is called sector area. And I don't even know if I have to, I don't even know if I have to mention this one. Let's say I've got a pizza and I've eaten this wedge of it. Okay. And I want to know not just the distance or the length of the crust, but I want to know how much pizza I've eaten. I would need to find the area of that Pac-Man shaped sector. Let's say this is, I don't know, 60 degrees. I'll jump back to degrees. I'll jump back and forth. So we've got 60 degrees. And let's say the radius of this circle is, actually no, let's say we know the circumference. The circumference of the of the circle is 10 pi. And we want to know the area of the green sector. Now that Final Fantasy VII has been remade, I actually kind of want to use this sector area thing to try to estimate how much of Midgar falls in Final Fantasy VII. I don't know if you have any idea what I'm talking about, because Final Fantasy VII just came out with the remake, and the original is before your time. But if you know what I'm talking about, there's a point where the city, which is kind of shaped like a pizza, one of the wedges, they destroy the pillar out from under it that holds it up, and the whole thing just crashes down. And I kind of wonder how to figure out the area of that. Anyway, we're going to solve this exactly like we're going to solve arc length. It's just that instead of finding a fraction of the circumference, we are finding a fraction of the area. So 60 over 360. Right? We have 60 degrees. There are 360 degrees total in a circle. And we're going to multiply that by the area of the whole circle, which is pi r squared. Pi times r. Ooh, we don't know the radius. Oh, woe is me. I don't know the radius. I'm scared. We're so close. We're almost there. But we need the radius. We don't have the radius. All we have is the circumference, which is 10 pi. Well, if we remember that circumference, which is 10 pi, is equal to 2 pi times the radius, well, now we can solve for r. Divide both sides by 2 pi. Pi's cancel. 10 cancels with 2. We end up with r equals 5. You won't always be given directly the information you need. You will always be given the information you need, but you might have to work for it. And it really all depends on how difficult the problem's supposed to be and all of that. While we're at it, by the way, 60 over 360 is 1/6. Looks like Nate either disconnected or took off. So we get area of the wedge is 1/6 times times pi times the radius squared, which is 25. We get 25 pi over 6. Boom. That is the short version of every assignment that is currently out for Khan Academy this week. Isaias, are there any questions? You're the only one that's left. Doesn't look like it. Hold on. Okay, so in future videos, this week is going to be all about radians, but really like this right here, what I just did, pretty much encapsulates the Khan Academy aspect of things. So I'm hoping folks will watch the videos because there's a lot more to this radian thing, and it's going to get complicated, but it only gets complicated in baby steps, right? It gets a little more complicated, but if you understand it, the next step is only a small step. But if you don't understand the current stuff, then understanding the next baby step is going to look like a giant yawning canyon instead. I also have some fun videos planned. We're going to look at some pizzas and use this math to talk about pizzas I really do want to put together a video on Final Fantasy VII. That's really about all I've got for today. So unless there are any last minute questions, again, as always, email me, show up to more of these meetings. Thank you. The fact that the two of you were with me here counts as your attendance for the entire week. So if I don't even see you again for the rest of the week, you will still be marked here. I hope I do see you again, but you know, you have reached your commitment for the week, and well done. Thank you for being here, and I'll catch you later.